analyzing time and growth, as well as validity threats, modeling errors, and some guiding principles. So these will be things that we'll kind of introduce as overviews before we get into the nuts and bolts of the different techniques. Now, a panel model is our simplest one, where we're looking at the individual differences standings. So we want to know, is there a variable, for example, in this case, X, that might be predictive of the changes in Y? And so with just the simplest of models, 2 time points, and I'm using boxes here to represent a panel model, that we see, is there an association between X and Y when Y is measured at a later time point? So this first parameter, or this first pathway here, is controlling for prior levels of Y. Is there an influence of X on Y? And in the next slide deck, we have those parameters labeled. So we have B1, which is our autoregressive, our individual rank order stability. And then we have that cross-lagged path, which is evaluated as the strength of the association of B2 controlling for B1. So again, we're controlling for prior levels of the individual standings in the parameters. We can also have X at a later time point, so that we can have Y predicting X and X predicting Y, so that we can look and ask questions about, is there a preponderance of influence from X to Y versus Y to X? So we can look at the magnitude of those cross-lagged pathways to evaluate, again, the rank order predictive ability of X to Y versus Y to X. This is a panel model over 5 time points that I have kind of as my background. So the difference between a panel model and a path model is whether or not I'm using a circle. And when I use circles, that means that there are indicators underneath the circle. So I'm using manifest variables as indicators of a latent construct, so that I can fit it as a panel model. Otherwise, if I'm using boxes here, then it's a path model, and I'm not correcting for measurement error. Now, growth curve models are another popular way to analyze longitudinal data. Now, what growth curve models are trying to do is to take the data points for an individual, right? So in this case, I've got 4 data points, and I'm going to represent those 4 data points as a intercept, or a starting point, and then a slope, and then I'm going to have deviations at each time point from that particular slope. Okay? So I'm trying to characterize each person's change pattern as a within-person intercept and a within-person slope. So growth curve models are disentangling the between-person differences from the within-person differences. Okay. So I'm looking at the intra-individual change over time, but I'm doing that with multiple people. So I can look at average patterns of growth, and I can look at variability in that within-person change, or the between-person change in the within-person, or the between-person variability in the within-person change. So here's an example looking at a dozen individuals. Typically, when we do growth curve models, we're going to have more than a dozen. We're going to have still maybe 100, 120 individuals, but we'll have multiple time points. To do a growth curve model, we typically would need at least 3 time points. If we only have 2 time points, then Jason, we're doing a simple difference score. But when we have multiple time points, we generally want to try to represent that as a slope rather than a difference score. There are a number of problems with difference scores. Alex Schumann and I have a paper talking about some of the problems with difference scores. There are also some issues with synergistic relationship over time, with a correlation of maybe 0.7. Right? And we'll see an example of that here as we move forward. And now, Aaron, the P technique of this is going to be treating each time point as a case. So rather than being an individual, it's going to be a person's scores over time. So your to-moment assessments will be stacked so that you have an X variable and a Y variable. And this is day 1, day 2, day 3, day 4, or maybe it's morning, afternoon, evening, depending how intensive your momentary assessment is done. And dynamic P technique is where we take these data and we lag them, right? So here I've got my time 1, my first observation of the individual. But what I'm going to do is I'm going to lag it over here. So I'm going to have an X, which is T minus 1, and a Y, which is T minus 1. So I put on the line for X2 the score for X1, so I can look at the correlation between yesterday and today. Every instance of yesterday and today, so that I can begin to look at the day-to-day associations, right? And so we can do multiple regression, we can do path analysis, but we can also do structural equation modeling. And in the example that I'm going to pull up and bring back to talk about, and in the example in my book, I looked at the changes in positive and negative affect across 3 subsequent days. So I have basically every instance of yesterday with every instance of today with every instance of tomorrow to look at the day-to-day fluctuations in positive affect among 5 pregnant women where they were assessed across 100 and some odd day, I think 102 days. Right? And so it became a multiple group longitudinal model with 3 time points, yesterday, today, and tomorrow, that I was able to model and represent and look at the day-to-day fluctuations in positive and negative affect as a standard structural equation panel model. And I could have also fit it as a growth curve model, because when I lag it, I got 3 time points. I can look at intercepts and slopes across time for these 5 women. So the P technique is basically, now here's the other thing about P technique version is you can fit panel models and you can fit growth curve models, but you're doing it as a multiple group comparison typically. Now I can also do a multi-level version of this if I had, say, 40 individuals where I had intensive measurements over time. Now I can do it as a multi-level version of a dynamic P technique. So the question there is, how many individuals do you have and how many intensive time points do you have? So we can definitely talk about those issues and when we get into that, either through consultation or finding a separate time when I can do a presentation on P technique for those of who are interested in the analysis technique. All right. Again, panel models generally focus on the stability, the prediction of the between person differences, rank order, and then I'd say here at the expense of information about means, but also it can bring in means. And so one of the cool things about panel models is I can do a mean and covariance structural model, and I can look at the changes in the means, not necessarily as